Thank you very much, and please go ahead.
Thank you, Laura, and thank you everyone for being here. So in the presentation of today, we will start by giving a few words of the objective of the two tools that we are going to present today, which are Examon and Countdown. And the presentation is split between me and Federico Tesser from Cineca. And I will start giving some introduction, then I give a word to Federico that will introduce Countdown, and then I will come back to me to introducing Examon. So the first few words to put ourselves in a space. So we are coming from Bologna city, which is a city in the center north of Italy. It's a beautiful city for being historical, but also as the oldest university in the world, as well as it hosts several computing centers. We are also famous for calories, food calories, but we are becoming nowadays also as a city really focused on flops, so performance calories. And indeed, we do, the reason why we have been so active in the field is that we really, by also the position of the city, we feel the importance of improving efficiency of supercomputing centers as Bologna city is becoming central, unique in terms of data center density within the city. So the idea of the research and the tools that we are presenting today is to provide holistic monitoring of computing systems, where holistic monitoring targets the idea of collecting massive amount of information from the computing systems and then to pipe them to AI pipelines to extract information, not only but also create dashboard and feedbacks to the administrators of the systems. The idea is to be capable of combining AI with holistic monitoring, is to improve power consumption of the data center, as well as to be capable of conducting anomaly detection and prediction to components and to identify misbehaving components to lead and to use this information in advance to optimize the way in which the systems is utilized. On top of that, we also have been developing the technology for improving energy efficiency, where the focus is to have a sort of press button technologies for saving energy. So from that perspective, the idea is that when the system is not working, consumes an idle power. A supercomputing system is not working, consume a level of power which is idle. When we run an application for the way in which HPC applications are constructed, the idea is that the system is utilized 100% during the time of application. And so the power consumption of the system goes to active power consumption. However, there are phases in the application where either the computation is not needed because there is a communication or slack of different sort of slacks in the application, such as communication slacks, synchronization slacks. And the idea is to have a press button technology which does not involve user intervention, is completely transparent to the user, which can be just activated and magically we reduce the power during the consumed by application in the system when it is not needed. So I will now give word to Federico that will introduce Countdown and provide you details on the Countdown technology.
Thank you, Andrea. I'm sharing my screen. Share. Okay. So, okay. Andrea spoke of a sort of magic button, to automatically reduce the energy consumption power at job level, at job level necessities, and we introduce here a Countdown, which is actually a tool to identify and automatically reduce the power consumption of the CPU cores during the execution of the communication phases for a pure MPI-based application. Countdown is a tool developed in conjunction by Cineca and Unibo. It's a project among them, and it's still in the development phase. It is a pure reactive mechanism, which is based on timer to start its own operation to reduce the frequency at which the core runs. Here there is a synthetic image to show you the logic behind countdown. You can see that on a process there is an applicative which is composed by application events and MPI events. And the idea of countdown is that during the MPI events, the frequency of the core which is running the process can be reduced and then restored up when the computational part restart or when it is needed to be more responsive. Here you can see that the automatism behind countdown. He knows when he enters an MPI event, and if the MPI event lasts until a threshold, which is 500 microseconds more or less, MPI then trigger is called back to reduce the actual P state of the core which is running the actual MPI process. When the event finishes, it restores the frequency at higher level as possible. Another version of countdown is countdown slack, in which it has been applied the same logic, but the frequency reduction is limited just to the slack time, which is the amount of time that we have all the processes involved in MPI events wait between the first and the last processes involved to reach the same MPI call. So there, the amount of time usually shorter than the previous mechanism of countdown, and the frequency is restored at the higher level for more time. This is a representation of the runtime system of countdown to be used. It just need to the deep reload variable to be exported with the path of countdown library, and then the pure MPI application, when it calls the MPI function, it will actually call the wrapper inside the lib countdown, which will do their magic, and then call the PMPI relatives function to call effectively the real MPI implementation of the communication needed. Countdown also gives you the possibility to trace the events of your applicative with a sampler, with a sampling for each delta t chosen by the user. At the moment, the login phase is done per node by a local master, and the counters needed to be to fulfill the traces are instrumented using Linux perf, and tracing can be done on CSV files, but there is also a POC for hierarchical data format, HDF, because if you want to scale down the 1 second limit at the moment for our traces, we need probably we need a different data model and data format. So the idea is to move to HDF, parallel HDF, to be compressible and parallelizable. Sorry. Here is what I already said. And there is an example of countdown in analysis mode. I showed you previously countdown enabled, the countdown slack mode. For having just the traces of your applicative, you have to enable countdown in analysis mode, simply exporting another environmental variable, which is countdown enable, and there you can choose analysis, one for the normal modality, so energy and tracing, and Slack for the Slack and tracing. Here it is reported on the left, a simple naive root file mode, just to give you an idea about some of the more important information that you can extract from the output of countdown, reported in the red rectangle on the right. You can see memory data volume, memory bandwidth, and the computational intensity obtained from countdown. A little note was that I don't know if there are users involved in using Liquid, but until now, which is the version is 5.3, Liquid has some problems, some already well-known problem from the user to correctly evaluate the computational intensity of the code. That's something they well know, and that's due to how Liquid at the moment final sum up the information obtained per thread, per core, per socket, and also per node at node level. But I mean, that's not. I don't want here discredit Liquid. Liquid is a very good and valid tool we use also to counterpart the result of the countdown. The developers are very prepared person. I just want to say here that we did something that something cool, and that at the moment a tool as a Liquid, but in the next release I think that they will fix it. At the moment has some problems to report. So if you tried Liquid, also try countdown. That was the adverts, and no bad things against Liquid at all, definitely. Countdown reports. As I said, I showed you the final output report of countdown, but you can ask him to report time series report that will be presented both in aggregated and distributed way in CSV files separated, where you can find specific information for rank, flop cycle, frequency, memory data, MPI rank. For example, how many calls for each type has been invoked by the ranks. Countdown can give you, for specific rank, how many MPI event and what type have been called. And the number of the type of MPI calls for which countdown was enabled, but also for the ones that countdown just reported. Okay, so the totality among the one which did not trigger the callback because they were too fast, and the one in which instead countdown actually applied this frequency reduction. Here at a simple slide to show you what you can do with the CSV files obtained by countdown. You can see that is reported, they are reported per node. You can see two CSV files, and in using pandas, I got the average frequency of the first socket, and while in the second one I got the average CPU load of the second socket. If I not see data, yes, data 02. So they are quite useful and and usable in a very easy way. Countdown result is a simple test to show you the capabilities of countdown. We use the benchmark ES class E from the NAS suite, very MPI bound. Countdown measured 57% of time spent in MPI events, and we use a couple of nodes of our system. We use the Examon Platinum 8276 with a minimum frequency of 1 GHz and a maximum one of 3.1. Doing the math, so giving the percentage of time spent in MPI events, we would expect if more or less an average frequency of 1.9. Okay, doing a minimum frequency for the MPI events and maximum frequency for the non-MPI events. And in fact, applying countdown, we obtain this. This is the reduction frequency obtained just with countdown enabled, and we got a very little overhead. The time to solution augmented of 1% using countdown in analysis mode, and the 4% using countdown enabled. Okay, you see on the upper left the mean the mean real times on the overall test run for the benchmark. If I remember, were like 100 times for the same benchmark. Moreover, here we can see that we got a drastic power and energy reduction, more or less of the 20%. So we can say that in this case, we got a very good energy and power reduction compared with a very little overhead in the time to solution. Sorry, that's it. That's it as a simple example, just to show you the capabilities of countdown. I can just give the word back to Andrea if you want. Maybe I got too fast, I don't know.
That was perfect. Thank you, Federico. So I will just
stop sharing.
We'll share the slides. You should see the presentation back again.
Yes.
And you can hear me. Perfect. Thank you, Federico, for the nice presentation on countdown.